It's cute. That didn't disappear on me. There we go. Okay, everybody see everything okay?
Yep.
So one of the last time we got together and I did a little program, I had mentioned something about a really neat application out there called HamClock. And it's a kind of a big spectral view of what's going on in the airwaves out there. Lots of good information on that. Well, the end of January, well, let me back up a little bit. So the guy that wrote all that stuff, maintained it, kept the server up and going, he passed away a while back when it became a silent key. So nobody was doing anything with it, and somehow the server for serving up all that information kept on running. And some people made the decision it was time to unplug that application. So normally a ham clock for the local hams, that usually ran on a Raspberry Pi. So there's a whole bunch of Raspberry Pi out on the market that's not doing anything at this point in time. So that application is gone forever. There's been a lot of discussion about resurrecting the server for driving this for ham clock. But one of the things that has just recently popped up towards the end of January was a application called OpenHamClock.com. This is takes a little different way of doing things. It's a more modern way of doing it, and this guy runs as a web page. So if you have a pen or a pencil or something to write down OpenHamClock.com, punch that into your web browser, and see what pops up. So what'll pop up is a page like this. So it gives you a real nice, this was taken probably, about 6 o'clock this afternoon or something like that. Actually earlier than that, it had to be probably about 4 or 5. So it'll give you a nice view, very similar to PSK Reporter of what's going on with who's talking to who, shows you what bands the communications are going on. You can get in there with your cursor and pop on one of the pins and it will give you all kinds of great information. So the left side tells you a whole lot about what's going on at your location. And you can also put your cursor on some place on the map and it will also show you both the um, short path for where you want to point your beam on where you want things to go, and it will provide that information. But anyway, it gives you a bunch of solar indices. The other thing that I really like down at the bottom left there is the void cap. Gives you all this predictive information on where you should be able to get DX and where how things are going. This the mapping hasn't got updated yet. Mind you, this stuff is evolving every week. There's new features getting popped into this thing, so it's moving along real quickly. And one of the things the old system had a really cool ability was you could turn on this void cap stuff, and you could see where your MUF is, minimum usable frequency, on that map based on where you are at. You can see where that RF, depending on what band and what frequency, should be going to. Very, very effective tool to figure out what bands you want to get on and where you want to operate. Over on the right-hand side is kind of a running tally of where you have kind of like PSK Reporter just showing you, or it's like a DX cluster. There we go. That's the word I was looking for. It's a DX cluster showing you a lot of stuff that's going on and who's making contacts and on what bands. So it gives you an idea of what bands are most active at this time. So that's all nicely color coded. The bottom part of it, for Ron, this is most interesting. It'll show you what's activity you're getting on POTA. So if you're a POTA person, that gives you a good track on what's happening there and what bands and what frequencies there to work POTA stations. And then just above that, it gives you an idea of what DX expeditions are going on and what's happening. You can Click on that. That'll open up a page and tell you more details on what's happening with the D expedition. Very, very powerful tool. Um, I would highly recommend that once you look at this, bookmark it in your browser and come back and look at it. And I actually start my morning looking at this to see what's active and usually chase a little DX in the morning before I go off and get some real work done. But cool tool, really like it. Glad to see it there. And also, let's see, yeah, okay, the maps. So up in the upper right-hand corner, this one here says hybrid. You can click on it and put up different kinds of maps that tell you different kinds of information. So it's really cool. And that whole map area, you can zoom in, zoom out to see more details as you move around. They also have a satellite view. You can bring up a satellite view and you can show where the satellites are, like the International Space Station, on where it is in the orbiting process. Really cool stuff. Okay, next one. Little stuff on some DX updates. Bouvet Island. It's down in the Antarctic. It's number 10 on the most wanted DX list. It has had more troubles in the last, probably 6 years on activating that island. It's always something gets in the way and screws up um, the expedition that's going there. So this expedition was supposed to head out on the 1st of February. They had a 2 week delay on some other repairs that needed to be made on the ship. Um, so it was 2 weeks late leaving. When I last looked at the ship location, it looked to be about 200 miles off of Cape Town, South Africa. So it's another day before it's get into South Africa. So Cape Town. So once it gets in there, then you have a crew that needs to load up all the food, all the equipment, people, probably 2 days worth of work to get out of there before they can start heading down to Bouvet Island. So it's about a 5 to 6 day trip down to Bouvet Island, depending on winds and weather condition. Um, as a personal note, for me being have spent some time in Antarctica and understand a little bit about what happens down there. Right now that's summertime down there. It's this so you're in mid-February. That's virtually the end of tour season for Antarctica. So when you get to the mid part of February, all those tour companies are starting to close up things because at that time, weather starts changing. By the time you get into the 1st of March, the weather has turned really bad. So these guys, just like some other expeditions, got delayed and they're going down, and it's going to be a real challenge once they get down there because what they're going to use there is helicopters to move the equipment off the ship onto the island. And then when they get ready to shut down, they have to use a helicopter to bring it off the island back to the ship. A couple expeditions back in the process, actually, they got delayed 3 days in moving equipment onto the island. And then at the end of the expedition, they were in the process of moving the last load off of the island, and the winds got kicking up so bad that they couldn't operate the helicopter. So the guys on the island had already packed up all their tents, all their food, and everything else. Actually, the food had already been packed off. So they did not have any supplies there. They had to overnight it and rough it with what materials they could find in the container there to keep them warm and to be able to survive overnight. So it's um, it's a tough island, really tough island, and I have to say at this point in time, if I was leaving out of Cape Town at this time, I would find something else to do. I would spend my time there in Cape Town drinking wine. Great place for wine. Another cute, interesting little place. I can't say the name there, but it's a little that KP5 NP3 Victor India. That's a small island in the Caribbean that this guy's been down there for over a month activating it. And he was supposed to pull the plug the middle of February, but somehow he's crazy enough where he's extending that trip down through the 3rd of March. So he's only running 100 watts. He running strictly off of solar power with batteries, and so he doesn't have a big footprint. And he's really hard to get, but I have managed to get him on 30 meters. Had a really good signal off of 30 meters, but I've tried and tried to get him on 20 all the way down through 10, and I have not been able to get him from down there. So that's another interesting island that I haven't seen that activated in forever. So that's the update on DX out there. And there's plenty of stuff going on. Sunspots are good. There's lots of stuff going on. So jump into it. So I thought I'd talk a little bit about noise canceling antennas. Actually, it should be noise canceling antenna systems. So one of the things that I've run into is that I have a number of friends that live in the city, and they just have a huge amount of localized electrical magnetic interference, EMF. And it's basically a RFI type of interference. And so bad where they have a standing noise level. Their noise floor is an S9. S9. So with the noise floor of that, if you'd like to do DXing or contesting or even rag chewing, it really puts a big strain on it. I mean, if a person had to deal with an S9 noise level all the time, it's like get out of being in ham radio. So one of my friends up in Scappoose, I keep bugging him about, buying the top of a mountain and doing a remote station up there, but he hasn't done that. He just doesn't have enough pocket change to end up buying a big chunk of land on top of a mountain. Plus the expense of putting in a remote station and then all the networking that needs to get done with it is it's pretty involved to make that happen. So he's stuck there in Scappoose there, and he's not willing to move out of that area. So he's stuck with this S9 signal. So that means, think about this. That means every time you get on the air to be able to hear anybody, their signal has to be better above S9. Now, usually it's going to have to be 2 or 3 S units above that. So you're going to be at least 10 over before he's going to be able to hear you and work you. So if DXing is your passion, contesting is a passion, real problem. So with that kind of noise level, it means over 50% of the stations that are out there, you aren't going to hear or see or know about. They're going to be completely covered up with that noise. So this is not an uncommon problem. It just seems like I just know a lot of friends that live in cities, and they have a high noise level with all the electronics and everything that goes on. There may not be as bad as this, but I know a lot of them that have S4, S5, S6 noise levels, and it really causes a problem for them to try and get on the radio. Kind of, it's a big discouragement. So, what are some of the sources from these? So, if you live in a city, power line noise, that's always a big one. So, if you have power lines that run alongside your property, that's always going to mess things up. Manufacturing. So if you have some kind of manufacturing going on, a lot of times the tools, the motors, the air compressors, all of the machinery that goes inside some manufacturing facilities, they always generate a lot of RFI type of stuff. One guy I know lives, I think, 2 miles from a lumber finishing manufacturer. And they have this great big air compressor. It's a variable speed air compressor. When that thing cranks up, that just absolutely destroys 80 meters and 160 meters. This guy is a 160-meter hound. He lives for 160 meters. He literally can't work anything on 160 meters when that plant is operating. Another place, I have another friend that lives in Corvallis. He has two neighbors on each side of him that have solar systems. So in the morning, as the sun starts coming up, the solar panels start becoming active, and the charger starts trying to create power for the grid, and that just ends up completely tears up everything from 40, 80, and 160 meters. So I've been also in like RV parks and turn my radio on, and some guy down the road has a big inverter, another 2, 3, 500-watt inverter. He turns that on. The inverter takes that 12 volts and converts it into 115 volts for AC for like making coffee. And but that inverter just absolutely destroys the bands that I'm listening to. I have some friends that their HVAC system, anytime it seems like you pop into the newer stuff that has more electronics into it, many of the appliances, like even clothes washers, stoves, they have processors in there. That ends up creating problems. Well, a guy needed to replace his water pump a while back, and so he thought it'd be cute. He'd buy one of these ones that didn't require a pressure tank, and this is a variable speed pump that ends up just maintaining the pressure all the time without worrying about trying to take and just fill a big pressure container. Well, that thing there basically destroyed everything on 20 meters and 15 meters. And so he worked and worked with the company to get the noise down. They drastically improved it, but could never get all the noise out of there. Plasma TVs, hopefully TVs used to be absolutely horrible for making emissions. I think at this point in time, all the plasma TVs have worn out, and I don't think we have to worry about it, but there's always one outlier out there. But plasma TVs were just terrible, just terrible. So if you want something to end up dealing and canceling out the noise, at least I always, as an engineer, I start up with requirements. So when I'm shopping around for a system that takes care of my problem there, I want something that's versatile. So I want it to be able to work across all modes. So it'll handle single sideband, AM, CW, FM, and digital modes. And it will work on all bands. That's a big plate out there to take care of, but I'll try that anyway, at least for the beginning is for requirements. So I want it to improve receptions so I can pick up weak signals. I need to get rid of the noise. I need to lower that noise floor so I can see those weak signals that I need for my DXCC and my contesting. I want something that's targeted. In other words, there's lots of ways of getting rid of the noise, but you may not like how it does that and the consequences of it. So I want something that's targeted that just removes just the interference that is causing the noise. I don't want something that's super broad spectrum that just rips out everything because there's a lot of good, meaningful information in that noise or that's being covered up by that noise. So I want just the interfering noise to be taken care of. Everybody kind of get an idea of what I got for requirements there. So let's see how some of the ways that we solve this. So one of the ways you do it is there's a concept called noise canceling. And down on the left side here, don't know if my cursor comes across or not, but yeah, it doesn't look like it does. But the red, this is where you take two antennas. You take your main antenna that brings in all your normal signal. You take another small antenna that is focused in on capturing that noise. And then you take that no that auxiliary antenna and you flip over the polarity of that. You flip the polarity over. So what happens when you have two AC signals and you combine them and they are in opposite polarity? So one may be a plus 10 dB from coming from the main antenna, the one coming from the little auxiliary antenna, and we'll call that a sense antenna, also has minus 10 dB at that same point. If you add those two together, and that's easiest to do that in electronics, to sum things, you end up getting zero out of it. So over on the right side, if both those amplitudes are exactly the same but out of phase, it cancels out that particular noise. Well, that's a really simple explanation for it, and we'll get into more of the details. So let's look at a circuit diagram of what that looks like. So over on the left, top left, we have our noise antenna. And this is the antenna that is going to be doing the sensing of looking for the noise. Over on the right side here, we have our main antenna, the big guy. On these types of systems, a lot of times just to clean things up, you put in a bandpass filter to kind of clean up, make sure you don't have frequencies either above or below what you're looking for. That ends up getting pushed into this pipeline. It just kind of cleans things up and lets just the signals that we want to look at get through. You have an amplifier that basically takes that signal off of the noise of the sensing antenna, bumps it up. You have a phase controller, which you can take and vary the phase. It may not always be 180 degrees out of phase, and I'll explain a little bit why that later. And then you also want something that you can adjust the gain. So when you get a interfering signal coming in off of the noise antenna, you want that to end up getting into the summing. You want everything to be, if this is producing 10 dB worth of noise peak, you want the summing or the noise part coming in the opposite direction at minus 10 dB. You want them to be symmetrical. That will properly cancel things out. That signal then gets piped off to your receiver. So noise noise cancellation. So it mainly reduces the RF by summing signals from two antennas, two different antennas. And these antennas have different purposes. So you take the offending noise, that's that sensing antenna, from a secondary antenna, and we'll talk a lot more in detail about the secondary antenna and what it needs to do for you. But you take that information, you invert the noise signal by 180 degrees, you run it through a summing circuit that adds the two together, and when you have the noise in, the main noise in one direction, the offending noise in the opposite direction by 180 degrees, the two guys cancel things out. So in this kind of circuit, I've seen guys that they tout they can get 60, 70, 80 dBs worth of attenuation. Some guys say it's good for about 40 dB. But what the heck, 40 dB worth of attenuation to knock out noise, that's huge. That's huge. So it's it can be a very effective if it's done right, but the key is if it's done right. Let's see, I'm going to skip that. So let's look at some hardware. So out there, there's plenty of hardware to get your hands on. The upper left is a good old MFJ. Unfortunately, they're out of business, but you can look around at ham fairs and PayPal, and you might find one of these guys here. They do a very good job on doing things, but they're a little limited in power and a few other odds and ends, but they're very, very effective in doing it. There used to be, Time Wave used to have a phase canceling system. I cannot find that anywhere out there in stock at this point in time. So I don't know if it's no longer being manufactured or what's going on. So the bottom two is from DX Engineering. So that's the left side here, bottom left is the NC1, and that seems to be out of stock. I don't know if they're not making it or not. The NCC2 is in stock and has some very worthwhile features that, even though it costs more, that probably makes this a more valuable solution to solve your problem. So if you don't want to spend a bunch of dollars, there's a ton of kits and do-it-yourself systems. There are other variations of this hardware that you can build yourself and even buy kits for to build. So if you're interested in going this direction, you don't want to spend the money, take a look at some of the kits. There's also YouTube stuff out there that you can look at to see how you can go about building some of this same stuff. So the key part of this is that sense antenna, that auxiliary antenna. So pretty consistently, I was seeing this as a reference where you just take a 10-foot piece of tubing, you run coax to it, you take the shield, drive a ground rod in the ground, dump it into the ground, bring some coax on it, throw some beads on it. You know, 31 is good for your low frequency, or good for most of your ham bands. And that coax doesn't have to be high quality because all you're doing is bringing a very, very small voltage back. So you can actually, if you want, you could use TV antenna cable. Um, that little stuff that has that little tiny small internal conductor. So non-resonant antenna, doesn't have to be resonant. So that's what you can use. Now there's lots of variations of this stuff. So this is just one example. So let's get into that sense antenna because this starts getting into where the magic is that you can control yourself. So you really want to get to know the source of that noise. So you need to figure out, get out there with, one of those vector, one of those small SNAs or an AM radio or something to get out there and find out where the source is. Is it coming from your neighbor? Is it a grow farm? Is it coming off of the electric power lines? You need to figure out where in the heck the source is. So you want to, so so your success is going to depend on the type and placement of this antenna. So, I showed you an antenna that's in a vertical position. That may or may not be good because in a vertical position, that means you can also be picking up stations that may be of good quality that later on can be canceled out because it'll be coming from all directions. You may end up wanting to take and put it as a horizontal direction. You may want to place it in front of your house or something that shields where you get most, like most of our ham radio stuff is either north, south, and east. We get very little activity that comes from the west. So maybe you want to end up, hopefully the noise may be coming from the west side of your house. So that's where you want to put that antenna. So when you finally figure out where to stick it, now you need to figure out how to see if you stuck it in the right place and if you're getting the right results from it. So in this whole concept, you want to maximize the signal strength of the offending noise. So you really want to pick a spot and get an antenna in there that just collects all that RFI, all of the offending noise, and gets it into the antenna. You want to make sure that you minimize the good signals. So those antennas that, or those directions that, you work guys out in the east, across the U.S. So you might want to end up trying to figure out how to end up shielding that antenna from looking and seeing any of the signals coming out of the west or out of the east there, excuse me. So if you don't, so once you get this thing connected up, you want to end up running it into your receiver and you want to take a look at that. So first of all, if you don't hear all the noise that you're hearing from your main antenna, well, full stop. It ain't working. You're not going to come up with a solution. For this to work, you've got to try your best to just isolate that offending noise. And it's got to be on that sense antenna. So this is just a caution here talking about if you put that sense antenna in a place that receives all the good signals, that means that those all those good signals is going to get combined or added to what you're getting off of your big main antenna and canceling out all the good stuff coming off of your big antenna. So it's not going to work the way you want it. So I think you get the ideal placement of that antenna really important. You might want to look at shielding to make sure that it only receives signals from one particular direction. So that may, you might have to put up a kind of a metal shield or tinfoil shield or something like that. But you got to make sure that it really is optimized for listening and picking up all the bad signals. I think we already got this one here. So now that you've got everything all connected up and you got your little phasing box connected up to things, so let's talk about how you end up doing the adjustment on that phasing box. So there's a knob on there for your phasing. Turn that to 0 so you don't get any phasing at all. Okay, the signal from the main antenna and the sense antenna should be the same amplitude. Really important. So what you might do is just connect up the one antenna at a time. Just connect up your phasing antenna. Take a look, either like your S meter is pretty crude. If you have a spectrum analyzer or a waterfall, you can look at specifically and you can kind of figure out, you know, what the amplitude of that these signals coming in off of the sense antenna. So once you get that set, you can go to the main antenna and you can go through the same process there. Depending on the type of actually box you have, I guess it really is. You take your main antenna, plug it in, you use that as a reference on what you need for a signal noise. Then you unplug it and then plug back in your sense antenna, and then you have usually a little knob there that you can crank the gain up and down to get that sense antenna at the same level as what you saw with the main antenna. So once you got the amplitude set, now think about this. From the main antenna, if you got a signal coming in that is 20 dB off the sense antenna and you have one that's coming in at 10 dB, you add the 2 dB, that means you still got 10 dB worth of noise that's getting into your system there. It's not going to you're not knocking everything out. So it's real important to get those amplitudes set correctly and the same. So once you get it set correctly, then the next thing is taking the adjustment on the phasing and you adjust that until the noise goes away. And it will be amazing how that works. And then you'll find signals out there that you didn't know existed. So it's pretty easy to get at least 40 dB worth of correction out of that. And other places they say that you can get as much as 60 dB or better. But it's amazing how that works. So, a few other things to consider. So some of these phase canceling boxes are really receive only. Um, like that DX Engineering one, the NCC one, that is a receive only box. So if you have one of those things, and also a lot of these kits and stuff that you build, it's a receive only box. So if you have something like that, that means you can't transmit into that box. what you need is a transmit receive switch, which will take and the coax and loop around that box and connect your main antenna to your transceiver so you can transmit. And your TR switch will sense when you're in transmission mode and when you're in receive mode, or otherwise you just burn up a bunch of really nice electronics in the receive only. Now that's not all of them. Like the MFJ has an automatic TR switch in that. The DX Engineering, the NCC2, that has a TX switch into that, but it's also more money in there. But that's what you have to deal with. So let's wrap things up so we can get out of here and do something for the evening. Okay, so if you have a noise floor greater than an S5 or birdies, another one is just birdies. A lot of times it's not necessarily broad spectrum noise, it's just birdies that pop up all across one particular band. That's something you normally see like from an inverter or a variable speed motor, and you'll want to end up getting rid of those things. But anytime you start getting noise levels of S5 or better, you're not going to enjoy being on ham radio. It's going to be a pain because you're just not going to hear things. So you need to do something about it. This is how you end up fixing it. So consider acquiring a antenna phase and noise canceling system, and we talked about those things. Place the sense antenna. Placing that sense antenna is critical. That is the most critical thing that you can do. All the other stuff, the that phasing system there, that's just mechanically. It'll work, do what it's supposed to do if that sensing antenna is placed correctly. I can't underline that enough to basically say that that is the most important thing that you can do on the whole system. That's going to dictate how successful that system works. So, so the other thing is that as you adjust that phasing system, the other key thing is that you got to make sure that that signal strength from the two antennas is the same, is the same. So, and I worked through how that works and how you need to do it. But placement of an antenna and then in the box yourself, this is just the process of setting it up. You've got to set the two amplitudes correctly at the same values. So that's all I had for the program here. So anybody had any questions or anything from what I said?
Yeah, when I first moved here, I don't know where my video went here, but when I first moved here back in 2014, 2000, yeah, that's right. The and I set up a ham station after I lived in Texas for a long time before that, which and where I lived there was utterly quiet, which was kind of wonderful. It was, and the but here it was not quiet at all,
Mhm.
and I was kind of beside, and most of the time it was at night that it was really bad. And I found a site. In fact, I wasn't sure where it was, but it was NK7Z, and I am not exactly sure. I don't think I think he's around here somewhere, Eugene maybe. But he has a wonderful thing there. He has a multi-part thing on RFI, and the
Mhm.
part one is locating it.
Yep, that's Dave down there in
Yes. So
Eugene.
I gave him, I emailed him. He got back immediately and gave
Mhm.
me some suggestions. Most of them didn't apply here because in my neighborhood in Corvallis, it's all underground utilities. So going
Mhm.
around and, aiming an antenna at a pole mounted transformer, that it was meaningless to me.
Mhm.
But it turned out that I had a failing street light, which actually is right at the edge of my driveway.
Mhm.
And I called that into the city, and a week or two, they replaced it. And all of a sudden, my nighttime RFI was mostly gone.
Mhm.
But then there were some episodic things. And turns out those were very local. One of them was a older Whirlpool front loading washer that we had bought 20 years ago. And I didn't recognize that immediately, except my wife is, the laundry room is just, hop, skip, and a jump from my office here.
Mm-hmm.
And we replaced that and bought some nice pair at Costco, and that noise went away.
Yep.
And then there was one other thing. What was it? Let's see. It was also the other thing that he said to check were solar installations. Everybody around me has solar panels, but that was not the problem.
Mm-hmm.
And so there was another appliance. I forget what was it. Anyway, we did that, replaced that, and all of a sudden it's quiet. What a difference it makes.
Isn't that amazing?
So
Yeah.
anyway, that's my story.
Yeah. So one of the things I really I need to stick in at the very beginning of this program is that, that first part is, identifying where the source of the noise, because some of those sources you can fix, some of them you can't fix. And so this is going down the road of things that you can't fix. But there's a lot of things like, street lights, power transformers, power poles, um, uh, dishwashers, all kinds of stuff like that. There's a lot of stuff that you do have control over and can fix it. But, you know, there's limits because when you're in a neighborhood where there's a lot of compact people, you have neighbors that have dishwashers, you have other appliances that you can't control. And so how do you end up doing that? I mean, if someone, if if there's a bunch of green or blue light coming out of a house and you don't want to go over there and say, shut your damn lights off, it's making a bunch of emissions when it may be a grow farm back there in that house. So there's when you have control over it, fine, but when you don't, this is kind of something that'll help you be a ham radio operator and enjoy the craft. Any other comments?
Low noise
So,
environments do not good hams make.
Well, it used to be 6 meters used to just absolutely destroy a TV interference, and so hams were always getting chewed up for 6 meter operations. So it made it very delicate to be able to move that. Now that all the communications on 6 meters has moved to digital and also higher frequencies, um, we don't have that kind of a problem anymore. Any other questions?
so I will add that uh, I was at a conference many, many years ago, and there was a satellite team that had a lot of data that they were trying to downlink from their satellites, and they had a special license grant from the FCC to do this really broadband spread spectrum data downlink uh, on a 70 centimeter band uh,
Hmm.
adjacent to the ham bands. And when they most of the time things were great because things were quiet where they were had their big dish and they could get data. But every now and then the local ambulance company whose license was on that same uh smack dab middle of their special license uh would just blow them out of the water because they were and we're talking these guys were running like a 20-meter dish is what they were using to receive with. So as you can imagine, a 20-meter dish trying to receive a 50 milliwatt satellite made sense. But that 20-meter dish versus the 50-watt mobile in the ambulance driving by, it just blew them out of the water. And so they were trying to figure out what they could do, what they could do, what they could do. And and eventually somebody took a cheapy mag mount antenna and threw it up on a wood filing cabinet. So about as poor of an antenna setup as you could get, but it could hear the ambulance company just fine, and they plugged that into an SDR and did the noise canceling to zero that out uh, in the SDR, and most of the time they could actually get their downlinks by using that to cancel the interference. Uh, and granted, at the time, that was one of the big old, Edis research SDRs that I think ran for about 10 grand back in the day for the base units. Uh, but yeah, there are a lot of implications for being able to take advantage of that, the way those signals propagate and the math that you can do, uh, and uh, and a lot of the fancy SDR radios now you can play around and you can use this kind of technique to great effect.
Yep. Okay, thank you, everybody. Back
Thank you, Mike.
to yep, back to Anthony there.
All right. Well, thanks everybody for joining. And just as a reminder, hopefully in the next few days, we'll get the recordings for tonight's meeting and presentation up on the YouTube channel. So if you haven't seen those, W7PRA in the YouTube search should hold us up, and
Or you
uh,
can go to our website.
that too. Uh, and there's also like cool pictures and other useful information on the website that is not on YouTube. So, uh, but yeah, those will be available here shortly. And again, just a reminder, if any of you has the bug to you know handle money and or take notes or anything like that, please email the group, and information on elections and all that should hopefully be going out here relatively soon. In the past, well, in the past several years, uh, there hasn't been much for actual elections because we haven't had people to running for seats. But if there is the possibility for people to actually be elected versus somebody else, Ham Club Online has a wonderful ballot system that works pretty easy. And we can kind of throw that together as the meetings goes. But like I said, the last few times, that hasn't been necessary because we've only had one person running for each of the positions, which made the elections kind of superfluous. Uh, though it would be nice to make sure that we still know how to make the ballots. So feel free to throw your hats into the rings so we can make sure that works. And with that, we'll let everybody enjoy the rest of their evening, and we'll look forward to seeing everybody again in a month.
Thanks.
Good
Bye.
night, all.
Have a good
Take
night.
care.